Alright, we have a ball of mass m moving with the speed v0, and it collides with a stationary ball that has a mass of 3m. These are going to collide in an inelastic collision, so they're going to hit and stick together, and then they're going to move with some final velocity after the collision. We know that that final velocity should be less than the original velocity of the first mass. So we'll call this Vf. To figure out what that final velocity is, we're going to do the summation of momentum over the summation of mass. So sigma rho over sigma m. And the only object with momentum in our system is just that first mass that's moving. So what that's going to come out to is Vf will equal to mv0 divided by the total mass of the system would be the m plus 3m, so a total of 4m. We can see really quickly that that's going to reduce to just the original velocity over 4. So Vf here is equal to the original velocity over 4. So it slows down to 1/4 the original velocity. Okay, so it wants us to do a ratio of the final kinetic energy to the initial kinetic energy. We know that it's going to lose energy in the collision, so the final should be smaller than the initial. So our fraction should have a smaller numerator, a larger denominator. So if I look at the initial kinetic energy, Ki, that would be 1/2 m v0 squared. If I look at the final kinetic energy, when they combine, Kf, that is going to be equal to 1/2. Our combined mass is 4m. And then our velocity over here is going to be v0 over 4. And that's squared. So if we clean that up, let's see, that would be 4 over, so 4 squared on bottom gives us 16. Now our denominator of 2 from the 1/2, that's 2 times 16, which would give us 32. And then that would be m v0 squared. Okay. So we could clean up that fraction. So 4 goes into 32 8 times. And so this would be 1/8 m v0 squared. So that's Kf. So what it wants is a ratio of Kf over Ki. So Kf over Ki. Well, we know that Kf is going to be 1/8 m v0 squared. And then Ki would be 1/2 m v0 squared. Okay, so we can see fairly easily that the m's would cancel out, the v0s would cancel out, and then the only annoying thing is that we have a fraction over a fraction. So remember the trick of if you're dividing by a fraction, you can multiply by the reciprocal. So this would simplify to 2/8, and then 2/8 would simplify to 1/4. And so that would be my ratio, and it meets the standards of the final kinetic energy, the numerator being smaller than the denominator.